If I explicitly said, Jacob is a smart aleck, that's explicit. That is no doubt. If I imply that he is by going, being a smart aleck myself, if I went, oh, that was a neat answer. Did I explicitly say anything? No, but I implied it. And part of the root word of implied is also part of the root word of implicit. It means it's not defined explicitly. So if you look at this, some of the stuff I've highlighted here. Implicit differentiation is we can take the derivative even when we can't solve the equation for y. Okay, now stop right there. Up to now, everything you've seen, it's f of x equals blah, 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 x. X is on the right side. Yeah? Everything has been solved for y for you. Not anymore. With implicit differentiation, that's not always going to be the case. Take a look at this right here. Well, that's explicit. Either way, we should get a derivative of what? Well, the derivative of 1 over x, so that's going to be x to the minus 1 power. What's the derivative? Minus x to the minus 2 power?
How does that work? Power rule?
The power rule. Look at the thing at the bottom. Can you solve that easily for y? Look at it. I got y cubed. It's not just y. I've got a y cube in there. And a y. That would be kind of nasty. That would be kind of nasty. But I want to be able to get the derivative of that. And that's what today's talk is about, is how do we do that using implicit differentiation? Okay, keep in mind that when we have gotten the derivative, it's always with respect to x, right? It's always the derivative with respect to x. Okay, I put a box around this thing. The main thing to remember, some of the things in the notes, I didn't type out the notes. I appreciate Michael Lee let me borrow his notes here. But the part I've got underlined in green, when you differentiate involving y, you've got to apply the chain rule. Now, wait a minute. What's the chain rule? It says you take the outside picture first, get its derivative, and then you work your way in. Here's something you got to remember. Y is a function of x. Always. Y is always a function of x. So when you see a y cubed, we're taking some function of x and cubing it. Okay. So look down here. A. It says the derivative with respect to x. That's what this means right here. The derivative with respect to x. What do? We use the power rule. We say multiply the 3 times what's in front of the x. And then take 1 away from the 3 exponents. So 3x squared. What about y cubed? Now, the derivative with respect to x, I'm taking something and cubing it. In this case, it's y. Here's the crucial thing to realize. That y is a function of x of some kind. We just don't know what it is. It could be x minus 10. That might be what y is. We're not explicitly told. That y could stand for the square root of x times the sine of x squared. That's what that little y could stand for. So now what do I have to do there? I've got to take, look what I did right there, Power rule, I treated that just the same. But then there's another little part. That's the first part of the chain rule. The second little part is this. Now I've got to realize that y, being a function of x, also the inside part has a derivative. And that's what I'm calling dy dx. Now, if you were looking in some other textbooks, they'd call it dy dx y prime, because isn't that what it is? So you can either use dy dx or y prime. These two things are synonymous here. Look at C. It's saying the derivative with respect to x of x plus 3y. Okay, those are two things added together, so I can use the addition rule and say, well, what's the derivative of x? It's just 1. What's the derivative of 3y? Well, if that y were an x, wouldn't I just say it's just 3? If that y right there were an x, wouldn't I just say it's the derivative of 3x is just 3? I can't do that with a y, though. I've got to say it's 3 times the inside part of y, which is the derivative of y with respect to x. Okay, once that soaks in, then this isn't bad.
I don't even understand what you said.
You did?
I do.
Okay.
Then, could you write it as y prime, or would you have to do dy over dx?
You can. I could have written that derivative as 1 plus 3 y prime.
So y prime would be dy dx or interchangeable?
They are. Now, the textbook we're using, or not using in our case, uses dy dx. A lot of books, I think that's the more modern approach. When I learned it, we just called it y prime. It's the same thing. It's a lot easier to write. So, okay, here's the guidelines. First of all, differentiate both sides with respect to x. Don't go canceling anything out. However it starts off, differentiate both sides with respect to x. And then I want to get all my dy dx's, or y primes, on the left side, everything else on the right side. Then I'm going to factor out what I need to factor out so I can isolate y prime or isolate dy dx. And then I will pretty much have it at that point. So let's do this first one. When you see a couple, I'm hoping you go, okay, it's not that bad. So I've got y cubed. Now, first of all, I've got 4 terms on the left. 3 of them involve y. Only 1 involves x. So that means I can take the derivative of each of those and add them together. Yeah? All right, so what's the derivative of y cubed with respect to x? Well, it's power rule, so I'd say, so derivative with respect to x is going to equal 3y squared. That's the outside part of the chain rule. And then I'm going to use y prime because it's just easy to write. You with me? I could just easily put dy dx there. All right. That's my first term derivative, plus power rule 2y to the first power, y prime. Yeah. Pretend like that last y right here is an x. Wouldn't the derivative just be 5? So I'm going to put minus 5, but then I have to do the inside part of the y, which is y prime. Oh, here's one. Okay, 2x. Yay, we're on solid ground. What's the derivative of negative 4? 0, because it's a constant. Okay, so now then I'm going to take everything. I want to get my 2x to the right, so I've got 3y squared y prime plus 2y y prime minus 5 y prime equals 2x. Okay, now I'm going to factor, now every term on the left has a y prime in it, so I'm going to factor it out. So I can say, all right, y prime times 3y squared plus 2y minus 5 equals 2x. Yes? I want to isolate my y prime. You could be writing dy dx. That's the same thing. I'm going to divide both sides by this. So I've got y prime, aka dy dx, equals 2x divided by 3y squared plus 2y minus 5. And there is my derivative with respect to x of that whole nasty thing. Now you might be going, well, we don't know what y is. No, we don't. That's why this is implicit. If they had explicitly told us what y equaled, we could have done it the way we've been doing it. If they now mention to us that y is 3x, all we got to do is plug that in. And that y squared would be 3x squared. Or what if they said, at a certain point, what's the slope of that thing? Because that thing's going to have a slope. If they said at, pick one, make sure I don't end up with a zero denominator, 0, 4 or something. I just plug 0 in for my x, I would plug 4 in for my y's. And I would get a number. Well, we know it's going to be 0 here. What if I put a 1 here? Okay, so I'd get 2 on top, and then whatever that would figure out to be. There's no point in figuring it out, but we could, if they once tell us, oh, here's a point. What's the slope right there? We just plug it in. Stop right there. Now then, you might notice that B is really the equation of a circle. It centers at 0, 0, and it's got a radius of 3. Let's differentiate that with respect to x. So I've got, okay, two things added together, so I can just add their derivatives. So my first one, easy, 2x plus 2y, that's the outside part, y prime, equals 0. So I get my x's.
Where did the 9 go?
The derivative of a constant is 0 because it's a horizontal line. If I had y equals 9, the slope of that thing would be 0. That's what we're finding is a slope. So I've got 2y,
Slope word like
y prime equals what? Negative 2x. So I divide both sides by 2y. And I'm getting what? Negative x over y. So the derivative of this whole thing up here with respect to x is negative x over y, whatever y is. We just know it's a function of x. That's all we know. Now that one, could I have solved for y? I could have said, well, y squared equals 9 minus x squared, right? And then what? Take the square root of both sides? Plus or minus, because I'm putting a square root in there, 9 minus x squared. I'm going to get two answers. So one of them is going to be the top half of a circle, and the other one's going to be the bottom half of a circle. Let's look at C. I'm not going to divide both sides by x. That's our first inclination. Let's just jump in there and cancel stuff. If I did, I'm going to lose something in the process. So what do? The rule says differentiate both sides with respect to x. Oh, man, this is a product rule. I've got x times y squared. What's the product rule say? Take the first function, x, multiply it times the derivative of the second. So that's 2y, y prime, right? Plus the second times the derivative of the first. Well, what's the derivative of x? 1. That's my left side. On the right side, I've just got 3. Now notice there's not a y prime right here. Why? Because I just multiplied that second factor in the product times the derivative of the first. I didn't need a y prime there because I wasn't taking the derivative of y squared there. Okay.
The one where the one in parentheses come from.
It's the derivative of the x just by itself.
So then,
The left side's the product rule.
then you just wrote 5 squared there?
I could have just put in y. I could have put y squared there. All right, so now then, I want to isolate over here. I've got 2xy, y prime. I'm going to subtract my y squared equals 3 minus y squared. I'm going to divide both sides by this. So y prime equals 3 minus y squared divided by 2xy. So the derivative with respect to x is what we're seeing on the right-hand side. If they gave me a point, could I figure out pretty easily what the slope of that curve is at that point? Yeah, just plug it in. Notice all those rules we've been talking about, the product rule, the quotient rule. Oh, I hate to even use the Q word. They're so much fun. The quotient rule. Let's keep going. Okay, here we go. We've got one now that, another circle, right? They're going to give us a point this time. They want the slope of the following graph. They're not asking for the equation on this one. It's the slope. So let's differentiate both sides with respect to x. So I've got 2x plus, I multiply the 2 times the 4, y prime, yeah? See if I did my math right. Okay, I'm going to get 2x on the other side, so I've got 8y, y prime
So does
equals,
the 4 on the right side do anything if it just becomes a 0?
becomes a 0 because it's a constant.
So not,
If you get those
right,
pages,
we're just going about the slope, and that would just and that would just not affect the slope because it.
the slope is 0. If you think derivative equals slope, you're right. So now I'm going to divide both sides by 8y. And I get y prime, dy dx, equals what?
Negative 2x over 8y.
Or negative x, let me write it like this. Negative x over 4y. Okay, there is y, and everybody else, there is y prime, which is dy dx, which is the same as the slope of the tangent line. Okay, how do I get the equation of, well, that's the slope right there. It didn't ask for the equation.
But if you were looking at the equation, you plug in those points.
And that's, well, I want to plug in those points anyway. So I've got what? Minus square root of 2. I'm just taking these things now. We're going to get a number here. So minus that times 4 times negative 1 over the square root of 2. Yikes. So I've got negative square root of 2. I'll get common denominator here, which is square root of 2. So this would be 4 square root of 2 minus 1. All of that's over square root of 2. Check my math.
If it's multiplication.
Yeah,
Why do you use
Why are you
common denominator? So it just be.
Oh, because square root of 2, it's minus 1 over the square root of 2. That's times. Yeah, okay, so, yeah, thank you. So I've got negative square root of 2, negative 4 over the square root of 2. Now, that's looking better. All right, now then, what? If I keep change flip, what do I have? Negative square root, it's going to end up being positive, right? So I can kill my negatives. I've got square root of 2 over 1 times flip square root of 2 over 4.
2 over 4.
Mm-hmm. So my slope there is 1/2. Thanks for catching that, John. If we wanted the equation, that'd be pretty easy with those points. But it didn't ask for it, so let's keep going. Unless somebody has a question.
Wait a minute, so the, y prime equals negative x over 4y, that's the equation? And then the points plugged in is the slope?
Mm-hmm. I just took this and plugged in the point.
So for B, are you using the chain rule?
So say again?
For B, are you using like the chain rule?
For B, okay.
So our answer is 1/2?
So our answer is 1/2. The slope at that point, now at every different point on that curve, whatever it is, it's going to be a different slope. We just found it at that one tiny little point. Look at this. Okay, chain rule city here, right? So it looks like, zooming way out, I'm taking something to the second power.
So we would just convert this on the inside first?
Nope, inside comes last. So if you watch the video, I would call all that inside stuff U. So I'm really visualizing this as 3U to the second power.
Oh, yeah. I put it the way.
Okay, so I've got that 2 times 3, so I've got 6 times x squared plus y squared. Right? There's my inside part. Subtract 1 from this little 2 up here, and I have a 1 there. Now then I've got to get the derivative of the inside part. I'll put that in red. So I'm adding two things together, so I can just add their derivatives. So I've got 2x plus 2y, y prime. Yeah? Don't forget the y prime part. On the right-hand side, I've got 100 times, we got a product rule going on. So I take the first thing, what's the derivative of y? Be careful.
Y prime.
1 y prime, so just y prime, yeah. Plus the second one, the y, times the derivative of x.
So
Just y. Okie doke. So I've got 6x squared plus 6y squared. Scratch that. Let's multiply everything, then multiply by 6. So I've got 6 times x squared times 2x is 2x cubed. X squared times 2y, y prime. 2 x squared times this 2x right here.
Oh,
I'm just foiling now. Okay, so then I've got 2x squared y prime. Then I've got plus 2 xy squared plus 2 y cubed y prime.
What does a y prime even mean?
Means the derivative of y with respect to x. On this side, I've got 100 times xy prime plus 100y. Check my math. On this side over here, I've got to multiply by 6 now. So I've got 12x cubed minus 12x squared y prime plus, a lot of 12s here, 12xy cubed plus 12.
Why is it minus x?
Maybe it shouldn't be. 2x cubed. No, it shouldn't be. There aren't any minuses in there, are there? Easily fixed. Thank you. So that means this is better be a plus. Okay, where did I leave off? 612 y cubed y prime. Okay, and this is staying like this. Okay, I'm just going to start moving stuff around. So this 12x cubed, are there any more x cubes any place? No. So I'm going to move it over here. So it's gone. Got a y prime there. Okay, 12xy cubed, though.
Why can you get rid of the 12x prime?
You just moved it
I want all the primes on the left-hand side.
Okay.
So I just moved this thing over.
Wait, isn't it xy squared?
Is that a 2? That might be a 2. Can't read my own writing. It would be x squared y. Yeah, it's a y squared. Thank you. Crummy handwriting. Okay. So that's moved over. And then I've got to move this 100xy prime over here to this side. So that's going to be minus 100xy prime. That cancels this out. Over here I've still got 100y. And over here on the left I've got that plus 12x squared y. Oh, man. Plus 12y cubed y prime. Equals, I'm just going to leave that alone. Okay, so I'm going to pull y prime out. And I've got minus 100x plus 12x squared y plus 12y cubed equals all this stuff on the right. So my y prime, finally, is going to be minus 12x cubed minus 12xy squared plus 100y over negative 100x plus 12x squared y plus 12y cubed. Okay. Now, I could divide, I'm not going to do it because I've run out of room here, but I could divide top and bottom of that right-hand side by 4. And so I get negative 3x cubed, negative 3xy squared plus 25y, and then something similar on the bottom. And then I would leave it at that. Unless barring anything else, but probably the last thing I would do is just divide top and bottom of that right-hand side by 4. Making sense? Notice, is there any way we could do that with what we knew before today? I don't think so. Let's keep going.
They gave us the points to plug in.
If they, oh yeah, they did. Oh shoot. Okay. Do we need to do that, y'all? To plug in 3 and 1, just for the sake of time? Okay, if we got time, we'll come back to it. Oh boy, we get to find the second derivative. Okay, we got another circle centered at the origin and radius of 5. Let's see, what do we have after this? Oh, that nasty thing. Okay, we're almost there. Okay, x squared plus y squared. Okay, so I'm going to differentiate the left-hand side. So I've got 2x,
To the second derivative?
yeah, plus 2y, y prime equals 0. Yes?
Yes.
So I've got 2y, y prime equals negative 2x. We already did something similar to this. We just had a different radius, didn't we?
Divide both sides by 2y.
I do.
Y prime over negative x over y.
Uh-huh. Okay, y'all. That is dy dx, isn't it?
That's the first derivative, right?
Yeah. If you
Is it just something for the second derivative?
Okay, now then I take that thing and I differentiate it. Here it is. So now then I've got the quotient rule. If you'll hang with me just for a second. What's the quotient rule say? Take the bottom one, multiply it times the derivative of the top. So negative 1 minus the top times the derivative of the bottom. And that just be y prime over y squared. Okay. So I've got negative y plus x y prime over y squared. But here's where the trick comes in. That means negative y plus x times, what's y prime? What was our first derivative? Minus x over y. See, I'm taking what we got over here and just plugging it in. Over, excuse us just a sec, y squared. Which equals what? Minus y plus, okay, it's going to be a negative in it. Negative x squared over y squared. And we could mess around with that and reduce it some, but that's what it's going to be. This one in the notes, the next one, I worked that out. It is nasty. Trust me on that one, because we got trig involved. I'll work it out and show it to you. This thing, what are we going to do? Find the slope and plug the values in. And I'll work that out and add it to the end of this video. I'll work both those out for you.